All right, so here's what we're going to do. We're going to take those, how many was it? 12 parent functions that you did on the must-know functions test, remember?
Yeah.
And those are what we're going to use to do our transformations. Okay? So that was why they were so important that you learned them so that you could transform them. So we'll start with an easy one. I think the easiest one to transform is probably the quadratic. And so every one of those on those must-know functions that you did, we call those parent functions. And they're called parent functions because they are the most basic of that function family. Okay? They haven't been stretched, they haven't been shrinking, they haven't been shifted, moved anyway. They're just a basic. Everything that we do will be based off that parent function. Okay? So you have to know the parent functions inside and out. That's why we spent so much time going over those and testing on those parent functions. All right. So you have a cheat sheet in front of you, and it might not make a whole lot of sense right now, but hopefully it will in just a second. The first transformation I want to talk about with you is a vertical. Oh. My bad. Is a vertical translation. Okay? I hope we all know what vertical means. What's that mean? Up and down. Good job, Miranda. What's translation?
When it, like a mirror.
Okay, that's reflection.
No.
It's a slide. That's right,
That's
Caesar.
not what I meant. It's like, yeah.
You're talking about transparent.
You know how they have the things like in elementary school when you have a picture and you put like the glass down?
So translation is a slide. Okay, are y'all with me? Do you remember that from geometry?
Yeah.
So maybe in geometry you probably did something like you took a shape and since this is vertical, I'll do up and down. Maybe you slid it down so many units. Okay, we're going to do the exact same thing, but this time we're going to take that parabola, that parent graph that looks like a U, right? And we're going to slide it. Okay, and to do that, we can do it down or we can do it up. We take our equation, let's say I have x squared. Anything I add to the end of the equation is a vertical translation. Anything here is a vertical translation. So this would say go up 3 units. So you would literally take that parent graph. Mm-hmm. It would be, yeah, that's exactly right. Okay, so if I have this parent graph, y equals x squared. Remember you had to put those, what are the crucial points you need to graph? And for this one, we needed at least 3 points. We needed that vertex 1, 1, negative 1, 1, and it looked, ooh, Stacy. Oh my goodness. I can't hit that dot to save my life. Oh, I'm pretty tired, but not drunk. There we go.
I don't know, you went to that concert last night.
It was a Christian concert.
Okay.
And all right, so this is a translation up 3, which means every single point. And if you look at your little cheat sheet, the very first one says f of x plus c is a vertical translation up, okay? And it says, if you look, it's got a little thing there that says xy becomes xy plus c. Which means for every point that you had in C, this is my C here, is my 3. Okay, so for every point that you had, you add 3 to the y. So this was 0, 0, so it becomes what? 0, 3. 1, 2, 3. This one was 1, 1, so it becomes 1, 4. And same thing here, negative 1, 4. So this graph that is off that's ridiculous, and I'm sorry. It's just that same green parabola, but it just slid up. Everything slid up 3 units because it's a vertical translation. Does that make sense to you? any equation that you have, any equation in the whole wide world, it doesn't matter what it is. And so this is why we write it, this is why function notation says f of x plus c. It doesn't matter what you have. Yeah. Tell me when you're done. It doesn't matter what you have, okay? Whatever that picture is, whatever that graph is, if you just tack a number onto the end, what else did we do? We did the square root of x, right? If off to the end, I just say minus 1. Okay? That means I start with square root of x. That's one of those parent graphs again. 0, 0, 1, 1, and it went off like this. I take that same graph and it just slides which way how many? Down how many? 1. Everything goes down 1. Down 1. Down 1. This is that equation. Does that make sense? A vertical translation? Up, down. That's all it is. Up, down. Any of those 12 functions on that must-know functions test, just throw that number on the end and it shifts it up or down. Okay? You've got an up and a down there on your cheat sheet, and it tells you how to find the points so that you can graph. All right, let's do horizontal. Yeah. That's vertical translation. Let's talk about horizontal translation. This is the one that's a little bit harder to understand. Horizontal translation. Let's say I have the parent graph absolute value. Looks like this. What does that look like when you graph it? Y'all remember this. I hope you remember this. Yeah. The V. You're exactly right. Sorry, Charlie. That wasn't. Yes, the V. It looks like the V. It's just like the parabola, but it's pointed down at the bottom. Remember? All right. So, and the points start changing. I shouldn't say just like the parabola because they start changing a little bit as you go up. But we have these kind of same starting points here. Just like this. Now we know if we just throw a number on the end, like if I just came here and said plus 1, what would that do to the green graph? It'd make it go up 1, right? But if I put it inside, let's say I said that my new function was x minus 1 inside. Okay? Do you see the difference here? Hooked just to x versus thrown on the outside of the equation. See the difference? This is a horizontal translation this time. When you do horizontal translations, everything is opposite. Now, horizontal goes left to right, correct? So this looks like minus 1 would go left, right? But because everything's opposite, this is actually going to move right 1 unit. Okay? That's why this sheet is going to help you so much. Look at the next two. F of x plus c and x minus c. Those are translations left and right, and it tells you which way it goes. Okay? So 1 to the right means take every point here and move it 1 to the right. 1 right. 1 right. 1 right. Does that make sense? Let me show you on my calculator.
Wait,
I'm not going anywhere. I'm just.
I can't see what
Welcome. All right. Let me show you on the calculator. Let's do Math number, absolute value of x minus 1. So hopefully if I've done everything correct, my board's going to glitch out. Thank you for that. All right. Hopefully if I've done everything right, it's going to look like my pink one, right? It will have slid one to the right. So let's do Zoom 6. It did. Okay. Everybody okay on that so far? All right. Guys, this is kind of tough. I need y'all to stay with me. We are getting to new stuff now. We're getting to stuff you have not seen. So it's going to start getting a little bit harder. Tell me this. This is, I'm going to give you one of each and see if you can tell the difference here. It was horizontal. I have two different transformations here. And I'm really, really, really wanting you to see the difference in the two transformations. The first one, first of all, what's the parent graph here? Just x cubed without anything done to it, right? So the parent, if I think about the parent being x cubed, do y'all remember what that looks like? Yeah. Okay. See why you have to know these? You really, really, really have to know these. All right, so for the first one, what is happening from the parent to that one? Vertical, which way? Down, how many? This is a translation down, translation down 2. How about the second one?
Horizontal, right?
That's exactly right. This is right 2. It's always opposite whenever it's horizontal. Everything horizontal, that's going to include my stretches and shrinks when I get there. Everything horizontal is opposite.
Okay, well,
I might. Look in my middle drawer up there in my desk. And oh my goodness.
whatever, I'll do it.
All right. Here's what I want you to do. I want you to sketch a graph without using your calculator. I want you to graph the parent and then graph the transformation. So sketch the graph of the parent, which is just what? X squared. And then do your translations to get it to where it looks like this. You got 2 of them here, so you're going to have to interpret that. So try that real. All right. We said the parent was x squared, so I'm 0, 0. I'm 1, 1, and I'm negative 1, 1. So this is what I'm looking for, and this is what I'll be looking for as you graph. Okay? Now, tell me about these transformations. Alex is doing this, and he's right. What's that mean? All right, down 2. And left 1. Every point is going to go left 1 and down 2, okay? When we're talking about translations like this, it doesn't really matter what order we do those in. We can just, if we want to slide them both at the same time, we can, or if you want to do them one at a time. But each one, so this is 0, 0, is going to go down 2 and then left 1. Down 2, left 1, down 2, ooh, oh, and left 1. Down 2, left 1 for every single point. And if it's easier for you to slide that parabola down 2, stop, then take that one and slide it left 1, you can. Does that make sense, the translations there? Up, down, left, right. This could apply for anything. It doesn't have to be one of our parent graphs. For instance, let's say, y'all got that? You low-key confused? Let's do one more then. Let's do, give me another parent.
How are you from the start?
Those are the ones we took a test on, those parent functions that we did. That's how I'm graphing those. All right, so your most common parent functions, and there was 12 on there, and you need to know them all, but the ones you really, really, really need to be able to graph, like in your sleep, would probably be the parabola, absolute value, yep, x to the third, square root of x.
Now, how many of those are the
1 over x. No, they're all different. These, you just took a test on these. What do you mean?
It's your calculator.
Yeah. So this is the parabola. This is the square root. I messed up. I'm sitting here watching y'all because I'm thinking about somebody said you can use your calculator. You'll have a function transformation test that will be no calculator.
That's funny. Like, that's not. Like,
X cubed, square root.
yeah,
I think if I study this little chart that you're giving me right now, I do it.
Yeah.
Will we get any parent function that has asymptote?
That 1 over x does. It's got the x and the y asymptote. And we use that a lot too.
If it ever says like a certain number into like transition, will it ever go to the line?
No, the asymptotes will also translate with the graph.
Oh, okay.
Yeah. Did y'all hear the question? If it's got an asymptote and you're translating, like you're shifting, the asymptotes will shift with it. So if I took this exact same graph and I shifted it 1 to the right, well then everything would shift 1 to the right, including the asymptotes. The whole thing would shift. Okay, so those are probably the ones you need to be the most familiar with. Yeah. Okay.
This is not looking too old. Right.
I'm gonna give you one more.
No, we
Example?
don't need
Yeah.
one more.
I need that last one on the left.
Oh. Let me take this a little bit further.
Uh-oh.
Is this still for the whole?
Oh.
If you started out with f of x and you needed to get to g of x, what has happened? Okay, so you subtracted 6.
You're right.
You're exactly right. All right, watch, look. How do you get from this to this?
Go right to
Huh?
Only transition.
Well, what I want to know, so the first one's already transformed, right? It's already slid left 2, but I'm not asking you how does it transform from the parent. I'm asking you how does G transform from F? You minus 6 on the X, right? Do we all agree with that? Yeah. To get from here to here, we did minus 6. Well, what happens when you subtract 6 from x? Because that's what I did. It's not outside the radical, it's under the radical. That means you went right 6. That's the answer. To get from F to G, you take F and you slide it right 6 units.
Oh, I get it.
You see what I'm saying? Anything hooked to X is right and left. Anything outside is up and down. I'm not looking this time from the parent, though. I'm looking from the f of x. So how do I make f of x look like g of x? Well, I'd have to subtract 6, right? Square root of x plus 2 minus 6 would give me x minus 4, right? So what did I do from this one? Well, I moved 6 to the right. Does that make sense? Right. Let me show you one more like that.
So,
No, go ahead.
anytime it's a radical or a, alright, well,
Square root?
I don't know what the other word is. Like, how do you know when it's, I don't know.
How do you know when it's horizontal?
Thank you. I want to talk about it. Yeah.
Okay, so horizontal because it was under that radical. Let me get
So
that.
if it's inside.
If it was there, that's vertical.
If it's inside the radical or the parentheses or the absolute.
Yep.
Okay.
If it's forced to hook to x, either by a radical, a parenthesis, something like that. But if it's not hooked in parentheses that way, it's just on the outside. That's up and down.
What if it was raffle, and it had, in the raffle it didn't hit? Like raffle, no, put the X on the outside of the raffle. But like we put onto the raffle, like a little small number, like 2.
We're not doing that. We won't do that. We're not doing that yet. Yeah. Don't worry about that just yet. Don't worry about nth roots just yet. How do I get from F to G? Okay, add 8, so up 8. See why this is different? Different. Looks kind of the same, but it's different. Left. Because if everything X is opposite. Left. Right. Now, 90% of the time, we're going to be moving from the parent function. But there are a few questions like this I wanted to make sure you really understood. All right, let me show you one more transformation, and I think I'll save shrinks and stretches for tomorrow. Let's do reflections. I like reflections. They're one of my favorites. They're really easy. All right, Miranda, here's your mirror. All right, reflections. You held up a mirror, and it reflected across the mirror, or I know you shouldn't use that word in the definition. That's exactly right. We're going to do either over the x-axis or over the y-axis. And here's the easy part. If it flips over x, by my desk back there. If it flips over the x-axis, that means every y is negated. What does negated mean? Okay, or give me another word. Opposite. And I like to use opposite instead of negative because if it starts out negative, then that means it's going to become positive, right? Okay. So every y is opposite, basically, is what that means. And if you flip over the y-axis, that means every x is going to be negated, or the opposite. I could have. Over the x-axis is going to look like this. If this is my parabola, what did I say? Oh my goodness. All right. If I reflect that over x, so if my x-axis became a mirror, what would it look like on the other side? And it would look just like that. It's hard to see a reflection over y with a parabola because they're the same on either side. So let me show you. A square root. Okay. If I reflect that over the y-axis, it looks like that. All right, so basically if you fold the paper on that axis, what it looks like on the other side. All right? Now, in the form of an equation, and here's where it gets a little bit sticky. Y'all got that? If you take every x and make every x negative in the equation, that is a reflection over y. But if you just take and put a negative sign out front, that is a reflection over x. Do you see the difference there? It's with that grouping deal again. Okay? If it's grouped with x, then it's hooked to x. We're in this reflection over y. If it's just out front and it's not hooked to x that way, then it's reflection over x. On your little cheat sheet, numbers 5 and 6 tell you how to find the reflection, and they're just exactly what I just tell you. You negate y or you negate x, or opposite sign on x. No, we'll save that for tomorrow. That's pretty hard. Let me show you an example and I'll be done. Okay, I'm almost done. Lily Joseph wrote that. All right, take a look. Two things are happening here. What's happening? If I'm talking about from the parent graph, what'd you say, Alex? Why is it reflect over x and not reflect over y? It's not attached, it's outside. That's exactly right. And it's what? Left one. So I need to first get that parent graph, right? That parent graph is 0, 0, 1, 1, negative 1, 1. The shift over is easy, right? Left one, just move them all over 1. Over 1, over 1, over 1. But what is this going to look like reflected over the x-axis? This is x. So this new point right here, this is 0, 1, negative 1, 0, and this is negative 2. How do I reflect over x? Make every x opposite, right? Make every y opposite. So this one becomes not 0, 1, but don't flip them around. You're doing inverse. Don't do that. Negate the y.
0,
0, negative 1. Negative 1, 0. So this one becomes this. Negative 1, 0. You can't negate 0. It stays there, right? How about negative 2, 1? What does it become? Negative 2, negative 1. You see how it changed? Only the y changed because I'm flipping over x. Does that look like it flipped over the x-axis? Yes. Does that make sense on reflections? Yes. All right.